Hi everyone, my name is Olaf Hannemann. I'm a co-founder of CVVC. On behalf of CVVC and CV Labs, I'd like to welcome you to today's event. A few words on CVVC. At CVVC, we seek to create an ecosystem where blockchain startups flourish. We do this through investments, CVVC, and our operational business, CV Labs. At CVVC, our focus is to invest in startups that build applications based on blockchain technology. To date, we've invested in 27 startups from 16 different countries and 4 different continents. Aside from our own investments, we're building investment products together with Swiss licensed asset managers for investors to co-invest alongside us or into other blockchain ventures. Through our CV Labs ecosystem business, we run co-working spaces in Zug, in Vaduz, and in Dubai. We organize events, startup competitions, as well as issue research reports such as the Top 50 report. If you're a startup, investor, corporate, or just want to learn more about us, check us out on cvvc.com or send us an email.
Welcome to the Crypto Valley, welcome to the canton of Zug. And thanks to CVVC for the invitation and for organizing this interesting event. As a former Minister for Economic Affairs of Canton of Zug, I could follow closely the birth and growth of Crypto Valley. And I'm very pleased to see how Crypto Valley has become one of the most major and most dynamic ecosystems for crypto and blockchain technology worldwide. The proof of the pudding is that we have already 11 unicorns here. It's quite a herd of it. Since 2 years, as member of Swiss Parliament, I can contribute actively to develop the legislation. This legislation is the robust basis for the tokenization of assets, and it offers the worldwide first trading license for digital assets. We need continuous innovation and the required talents. Therefore, an important pillar is the NTN Innovation Booster, so-called Blockchain Nation Switzerland, recently launched by the Swiss Blockchain Federation. This example shows how government, politics and industry stay together to create blockchain-friendly conditions. And myself, I stay committed to it like a shepherd to the growing herd of existing and future unicorns. I wish you an inspiring event.
Hello everyone and welcome to the summary of the Crypto Valley Top 50 report, published by CVVC in March of 2021. Let's get right to the Crypto Valley Top 50 report. Here's the key data. The Crypto Valley top 50 companies are valued at $254.9 billion. Total funding of the top 50 companies reached $3.7 billion. Total number of projects and firms in the Crypto Valley is now 960. The total employment of blockchain companies in the Crypto Valley, which includes Switzerland and Liechtenstein, is now 5,184. Crypto markets experienced a dramatic rise in the beginning of 2020. The valuations of the Crypto Valley top 50 companies increased from $37.5 billion to $254.9 billion. The Crypto Valley now counts 11 unicorns, up from 6 in 2020. Switzerland improved its regulatory framework even more with the umbrella DLT Act. When we look at protocols, most of the world's important layer 1 protocols make their home in Switzerland, with more and more looking at setting up here in Crypto Valley. In decentralized finance, or short DeFi, Switzerland is now also home to 2 of the most important DeFi projects, Aave for lending and Curve Finance for enabling liquidity of stablecoins. More projects are building important rails and infrastructure in DeFi. The clear regulation in Crypto Valley has been an advantage since 2013 when the Swiss government clarified how to treat Bitcoin. The year 2021 has started with a bang in crypto. And in the Crypto Valley, the excitement can be felt at every corner as more and more people and projects are moving here and join the thousands already in blockchain and crypto. Check out the report at cvvc.com/top50, and now enjoy the event.
Hi, Maksim Balashevich, founder and CEO of Santiment, data analytics platform for crypto assets. We are one of the top 50 startups in CVC, also in the report. And we are analyzing crypto assets from point of behavior analytics. And we do it for not only for major coins like Bitcoin, Ethereum, but also for more or less top 1,000 coins. Now, when we do behavior analytics, it demands specific sources of data to understand the key stakeholders, how they behave, how the value is flowing from one to another. And we're doing it now for 4 years. We founded company in 2017. And we have something to show in terms of scalability and interoperability. Why is it important? If we look one step back, we can say that in the last 2 years, we had one of the killing application, killer feature on Ethereum. Yeah, it's a DeFi. By the adoption of DeFi through so many sectors and by so many value and money flowing into it, we've reached the point when Ethereum network is used heavily. Some say overused, but the fact is it's used heavily. And there are ways how things are being solved in Ethereum. There are ways how things are being solved, and they will be discussed later in a panel by other protocols. But what I want to show, what I want to share with you, is some data and insights into what really happened in this DeFi exponential growth. As an introductory chart or visualization, I think it's very interesting and important to look into one specific metric. How much of Ethereum in the circulation has been deployed over these 2 years of DeFi revolution and currently used in a specific DeFi protocols. And we don't only look at this, but we compared to amount of Ethereum which is deposited on exchange wallets. And why we do so? When we look into history of each crypto project, it's always coming through the stages or cycles, which corresponds also with price cycles. And the first cycle is mostly about speculation or value expectation, what might happen with this vision, how big change can it bring. And there is not yet real usage of the network, or not much. And mostly tokens are used for speculative purposes or pricing in expectations of the future. And this can be reflected on the amount of tokens which are held on exchange wallets. There are other interesting metrics too, but it's like simplification. And as you see on the chart over the last 2 years, well, it took only 1 year for this chart, but if you look on longer, the tendency was always there. And this year you can see clearly slowing down, going down amount of tokens held on exchange for speculative purposes, and constantly growing amount of Ethereum used, deployed, locked for DeFi protocols. It's a very interesting metric to see, and the trend is not over yet. It keeps coming. And by doing so, we start from one metric which is mostly known and talked by many, maybe by all. It's total value lock, TVL for short. And it's mostly used as a measurement how much is value locked in Ethereum. The metric by itself is good as simplification, but not go into details which can be done better there. It is generally, we believe, is effect, not the cause. If we think about what has led to so much value, so much toxin, so much now adoption on DeFi protocols, then we could look into a few other things. How the value is created, by whom is it created? Is it created by developers? And also adoption by the users. But the first thing, and this is the first chart I want to share with you, is development, so to say, effort-locked development commitment to build the protocols. And this developer commitment, as you can see on the chart, is quite substantial amount. And this is one of the reasons why at the end, when it worked, so much value have been created, because developers have been working long time on, long before it became so popular. They started to work on it, and they did a lot of experiments. Now, the second chart which we can look into is, so to say, speculative or crowd commitment, and we will look in a specific way. The data we collect here for the chart, we sourced it from thousands of social channels, quite unique, and you typically don't find it on Google search, like Telegram channels and other social channels where crypto people are communicating. And in this metric, we show social dominance. Yeah? Like we all know Bitcoin dominance, but there is like social dominance. Amount of people who are constantly communicating about the crypto, how much is their talk volume is flowing or discussing DeFi projects. And as you can see in this chart, it's quite substantial, and it peaked already last year, and it's now went down and stabilized. And it shows that maybe things have moved already to the next big thing, NFTs. So by these two charts alone, you can see from different angles how it came to DeFi dominate space so much, or dominate talk so much, and what is the current result of it. Talking about people, crowd commitment, and where a next big thing might happen. Now, the full report we prepared for CVVC is a bit bigger. We'll also talk there about specific on-chain metrics like network adoption and growth, and you can download it on the link. I think it will be shared in the description of this video, and I encourage you to see it as we show the whole DeFi space from different angles. And I hope to hear now for the coming panel the ways how the issues or challenges can be addressed from different protocols, and I hope to see more developers and more adoptions for things we're building in crypto space.
Thanks everyone for joining in the audience, and it's a pleasure to have a panel on first scalability and interoperability in the context of DeFi, or the DeFi bubble we just saw recently, and very happy to have here the leaders of our industry. So happy to have here Dankrad from Ethereum Foundation, then Marcelo from Near, Joe from Polkadot, and Zaki from Cosmos. So it's really a pleasure, guys, to have you. And happy to have you aboard and talk about this, and to kind of try to dive straight into the discussion. I did a little bit of research and spoke with a few people about the two topics, and I think that most of our community first experienced those topics actually. A few people actually mentioned about the CryptoKitties in 2017 and the network congestion that we experienced back then. And then finally, during the DeFi bubble that happened in last year, summer of last year, a few more people saw what this means actually to have a solution actually that scales and also that works easily with other blockchains. So really want to set the stage of this discussion in that context. But of course, the panelists will try to answer those questions in a wider context and not necessarily just in the environment of the DeFi bubble that we saw and are seeing now. So to actually really dive straight into the discussion, I would actually like to ask or call out Dankrad. I think a lot of the spotlight recently was on Ethereum, namely because of the two upgrades that we saw recently, namely the Bitcoin chain and the highly anticipated rollout of proof of stake validation. So I think, maybe you can first walk the audience through those two highly important events for our whole ecosystem, but also to shed a little bit of light how you see sharding going forward as a solution actually on the scalability side, And also maybe you can share a bit of light how you saw the scalability issues that were present both in end of 2017, but also in the summer of last year and today. So I hand over the word to you, and glad to have you as a panelist.
Thank you, Anton. Yeah, I think like, well, I mean, I don't know, like on scalability, I think like on Ethereum, the problems were like pretty obvious in many ways. I mean, like from one side as developers, we're kind of seeing this with one happy eye, because it means like there's actually demand, like people really want to use these systems, and we now have proof for that, and they're willing to like pay actually exorbitant amounts even to use them. So the demand is there, but we clearly need to build the systems now so that that anyone like who wants to use this can actually use it at a reasonable price. And yeah, I mean, like obviously Ethereum has been criticized for a long time that proof of stake and sharding and everything has been promised for a very long time, and like there have been a lot of delays, to be fair. But also I would say like since last year and this year, like we are now delivering many of the things that have been promised, and it's going really well. So like these are really exciting years with obviously the beacon chain that has been launched in December, so still relatively recent. But the positive thing is it has been running incredibly smoothly. Like I guess like we are surprised ourselves a bit, because like the testnets, as some of might have observed, like had some problems, but happily we seem to have fixed most of these, and so far we haven't seen any like huge issues. Obviously we were very careful with the beacon chain, like it's currently not running any other production systems on it, because we really wanted to test it a bit more before we do that. But yeah, I mean, so far it looks really good, and so later, hopefully, I mean, I don't want to like make an absolute commitment yet, but from my personal perspective, nothing stops us from doing the merge, like transplanting Ethereum 1, everything that runs on the EVM onto the beacon chain in this year. So I hope that will happen. Which of course doesn't yet do anything directly for scalability. So the really big step will be when we enable the data shards. So what we will do is we enable Ethereum to come to consensus about basically very large amounts of data, like more than a megabyte per second, that can be posted to all these shards that we will enable, 64 to start with. But what that will enable is that people can build rollups to a much larger scale. So for everyone who doesn't know the details, rollups are basically this concept that you post data to a blockchain, and the normal consensus participants, currently that's all miners on Ethereum, but in the future it will be validators, so people who stake. And on the rollup, they don't need to actually validate what's happening on the rollup either, because the rollup comes with a complete proof that shows that it's correct, that's ZK rollups, or because it's a so-called optimistic rollup, where if something incorrect happens, someone can later post a fraud proof that shows and changes the state to be the correct state, essentially. So despite the consensus node not validating it, nothing bad can really happen, or at least it can be corrected if it does happen. And that has turned out to be a very powerful concept that actually we see now is like starting to get rolled out on ETH1 already, and can like basically provide 100x scalability improvements now, which is like very good for relieving some of the pressure. And with shards, basically, because all you need is really like lots of data being proved to be available. And with shards, like we get another factor of like around 100 on top of that. So yeah, I mean, incredibly exciting on the Ethereum front, and it's a very exciting time to be around this, because like you're not working in the dry and thinking, yeah, we need to solve the scalability problem, but you have actually like the users in your neck wanting this really urgently, and I think it's great that that's good way to build this, like to know what you know, like to get direct input so that you know that what you have to build. Yeah.
Thanks a lot, Dankrad. And also, you're absolutely right. I mean, sometimes having scalability issues, it means something very positive. There's actually a lot of appetite to build on top of Ethereum. So I think a lot of people see it in a very positive way about the future of our ecosystem, our industry. But also, maybe I wanted to ask you a follow-up questions. Definitely, when I was actually doing my research and asking a lot of people, everybody then asked, okay, but how do other projects, are interoperable with Ethereum? So how do you see actually the concept of interoperability when you are the most well-known used or blockchain where people build the most applications? So how do you see it from your perspective? Maybe the learning experiences that we can see going forward. Yeah?
Right. I mean, we are trying to be more interoperable. I think like in the past, like there were some blockers to that, like Ethereum using different hash functions and things like that. So we're now like really trying to be as close to like the standard as possible and enable that. I think there's basically, I guess over the years, it has turned out there's kind of one big blocker in a way to that, which I would say is the data availability problem, which just really means that in the end, like if interoperability means bridges, which of course not everyone thinks that. I know Polkadot has like a different kind of idea of it, but like if it's bridges, then really you have the problem that in the end they will kind of always be depending on the honest majority. And that is really something we want to move away from in Ethereum. So like our goal is, it's not completely there yet. I mean, ETH1, for example, doesn't have like concise fork proofs and that sort of stuff. But like in the long term, we're building everything so that you do not have to trust an honest majority of validators, and like the network really minimizes that dependency. And that's kind of one of the things where I'm kind of a bit worried about the bridges, and will always see them as a slightly weaker link of the whole system. But otherwise, like, I mean, we're definitely in favor. There will obviously be several projects and we should link them. But I don't think that link will ever be like completely as native. Like, I do not believe in kind of the adage that block space is fungible. I don't think it's fungible. I think there are differences between projects, and that's fine. Yeah.
Okay. Yeah, thanks a lot. And also I have the privilege to ask a lot of questions, but I invite the audience to ask the questions as well, and we will address them here. And also, I think you touched upon it very nicely. It's just that talking about interoperability is not just about accessing actually data from different blockchains in a safe and secure way, but also means actually interacting with smart contracts and decentralized applications, from different blockchains as well. So in that light, I would very happy actually to invite Marcelo, actually, if you can share actually a bit of light how Near is actually doing that or plans to do that, because I think it's really important topic for people to understand, that to build really a decentralized ecosystem for applications, we have to have interoperability both on application level as well. So Marcelo, please, the stage is yours.
Yeah, thanks, Anton. Thanks for inviting here. Well, actually, we have just released a few weeks ago our Rainbow Bridge, which is basically a bridge between Near and Ethereum, actually allowing to move in assets between both blockchains. So yeah, we might discuss about it, Dankrad, about your opinion on how this is actually not viable. So today is actually happening, the official release of the bridge. So I invite you all, you and the audience, to test it. You can go to ethereum.bridgetonear.org and try the bridge. Right now we have a few functionalities like moving RC20s from Ethereum to Near and move it back to Ethereum, so we can start building an ecosystem with current assets from Ethereum. How it currently works is actually in a way as decentralized as possible, I would say, because you only need to trust in the in Ethereum validators and Near validators that they behave like they have the same guarantees that have the Ethereum network itself and Near network itself. You may say like the lowest of them, but in any other regard, it's fully trustless. So basically, we are like building like clients. A near like client is being built with Solidity and deployed on Ethereum. And Ethereum like client was deployed in Rust and deployed to near blockchain, and we like run those like clients, and those clients actually allows us to build proofs of events happening in the other blockchain, and this effectively allows us to move assets between blockchains. There is off-chain components like relayers, but those relayers behave in a trustless way. You don't need to trust any of them. You only need to be aware that at least one relayer is running, but those relayers are public, like anyone can run those relayers, and they cannot behave maliciously in any way. In the current setup, there is a limitation about the signatures that are being used by Near and Ethereum, and because of that, like Near is using SecP signatures and Ethereum is using network signatures, and they don't have like host function for it, so it's pretty expensive to evaluate this. And for this reason, we have like a optimistic setup where we have a challenging period when we are running the Ethereum-like client. It's not verified immediately, but like to address this and to like because of this, like the period of time you spend moving one asset from Near to Ethereum, it's like 4 hours. We are addressing this by actually using network signatures on Near side that will be usable by the Near like client that will be executed on Ethereum. So it will be cheaper and it will no longer be optimistic. It's not the current setup, but it's planified to be deployed this year.
Cool, thanks a lot, Marcelo. Yeah, and also just reflecting a little bit, actually. So, my background is coming from the market making space, where sometimes actually, the technology that we use is maybe efficient and it works, but it's not really the cutting edge of what's out available there. And also reflecting like how much trust we put actually in a lot of different counterparties actually to actually enable us to transfer of assets between different chains sometimes actually puts a lot of things at risk. And for me, actually personally, a project that I know I've been following for a long time and I'm a big fan of is actually Polkadot. So actually very happy, if Joe can shed a bit of light, especially how you actually plan to enable the same level of security between the parachains and actually in the relay chain, because I think it's very important like for people to understand, just how much complexity there is, both from a security perspective, but from a governance perspective, actually we can have a secure way of recording data and also actually have it used for, applications such, that we're looking for automated market making protocols, potentially work between different chains, but also like the end users and the traders and the community that we have in this space. So Joe, the floor is yours. Thanks a lot.
Yeah, I mean, there's a lot of questions kind of baked into that, and I think I'll maybe leave the governance thing to a part 2 here. But yeah, so I guess like kind of like Dankrad was alluding to is that like if you have these different shards or like blockchains, if you will, kind of operating in the same context, then they kind of have these similar guarantees and they can operate like across trust bounds a lot more easily. Whereas like if you bridge protocols with different trust bases, so like Ethereum to Polkadot or something, then you do end up kind of trusting like the minimally secure one. And so like what we do like Polkadot, like our security model is basically that like there is a thesis that there's going to be a lot of blockchains in the world. So you could call them like shards of Ethereum or specialized like substrate-based chains or whatever you want to call them. There's going to be like more and more blockchains being developed, and security is kind of like by definition a scarce resource. So if you think about it like in a non-blockchain context, it would be like, physical security at a data center. Like there's only like so much security you can put there. In a proof of work sense, it's how many CPUs exist in the world. Of course, this is a finite number. And in a proof of stake context, this is like, well, how much value is actually securing blockchains? Like how much value is at stake? And value is by definition scarce. So if you start adding more and more blockchains together, you have kind of like an unlimited number of blockchains that you can imagine, and you have a finite amount of security. So this is going to get diluted. It's unavoidable. So what we did in Polkadot is like we kind of take all these parachains, which you could think of as like similar to shards in Ethereum, except like instead of having this generalized like smart contract state transition function, you kind of get to like create your own like specialized blockchain. And these all like tie into the context of the relay chain. So you just have this one validator set, which is the relay chain, that adds all of the security to Polkadot. And when you produce like a parachain block, it uses kind of like a, like from the relay chain's perspective, like a stateless validation. So like the relay chain is like kind of like running a light client to all of the parachains. Like what actually goes in the relay chain state is just the last state root of all of the parachains. And so the parachain that can actually submit a block with its list of state transitions, and also like kind of like a pruned Merkle tree, it only shows like a state tree of stuff that's changed basically. And you can, so this is called like the proof of validity block. And so you have like the actual block, and then you have this like bigger blob of data around it that actually lets a light client, which is the relay chain, validate that the state transition has happened correctly. So it really changes the security model for the parachain block producers, which are called collators. But these like they need to have the full state of their own parachain, and they can propose a block to the relay chain, which then takes care of all the validation and security part of it. And what that does for like the security guarantees is like, you know, if you're kind of like vaguely familiar with proof of stake systems, you know, you have this like BFT assumption that you need to have like 2/3 of your validator set that's like online and operating correctly in order to have like safety and liveness. And that still applies to like the Polkadot relay chain validator set, but it changes the security assumption for the collators because all they get to do is propose blocks to get validated. So you don't actually have this like BFT assumption of needing 2/3 of them to be honest or anything. You just actually like in theory, you just need one collator who's not going to censor transactions and is online to produce and propose blocks, and kind of like all the responsibility and slashing liability for approving like an incorrect block actually falls on the relay chain validators. So this lets the parachain kind of operate knowing that like, well, I can trust a message from another parachain because we share this common security guarantee. I know that like if I'm parachain A and parachain B sends me a message, I know that like there's no situation where that message arrives, say 6 seconds later, and in that 6 seconds that parachain has been attacked, and now it's like been reorged onto a different chain where it never sent that message or something, right? Like I have that guarantee because we're actually sharing the same guarantees. And so that's where like bridging comes in. Well, like if you accept a message from a bridge, you actually do have to accept that like, well, I don't think that like this chain has been reorged since it sent me this message. So I think like I've probably been going on like a little bit there, but I'll let you go for a follow-up.
Yeah. Sorry, yeah, and also, I mean, maybe actually some concept I think that's really, from my perspective, very smart and unique, actually, that you have a second layer of defense integrated within your solution. Actually, if something goes wrong, and maybe you can touch upon for the audience a little bit about the fishermen, how they actually operate. And personally, just thought this is a clever idea, actually.
Yeah, so this kind of like goes along with the data availability problem that Dankrad also alluded to, which is like, so if you say we have like 100 parachains and 1,000 validators, they get kind of like randomly shuffled around. So you have like 10 validators per parachain, but you really don't want to trust that like, say 10 validators are going to act honest, because like if you have 1,000, that doesn't really fit within your 2/3 assumption there. So you have like two things that you want to check these guys on. Like one, is the data actually available? And two, is it correct? So the fishermen actually check the correct part, but actually like the availability part is more interesting actually. So you kind of imagine this attack where the relay chain, just being a light client, it only has the state roots of all of the parachains. It doesn't have the actual state. So you could have a collator that proposes a new block that's a completely valid block. All the state transitions are completely valid, and it leads to a new state and a new state root. And it submits this block to the validators, who go around and check and say like, okay, yeah, this thing is valid, it works. We're going to apply this update. As soon as that collator submits the block, he actually just like pulls the plug and turns off the machine. And so now the relay chain would have approved a new state for this parachain. It has a new state root, but nobody actually knows the state that produces that state root. So the parachain would essentially be blocked. Like it can't produce any more blocks because it doesn't even know what state to build on top of to get to the next valid state. So the way we solve this is like those 10 validators actually have to take that whole proof of validity that includes all of the state changes to get to the new state root. And they break this up using a technique called erasure coding, which is basically like you take more information and spread it out. So like it would basically be like you give a chunk of information to a bunch of people, and you only need like some subset of those chunks to actually reconstruct the information. So they'll take these chunks, send them out to like all 1,000 validators in the system. So each validator actually gets like 1/1000th of like this big chunk of erasure coded data. And you have this kind of like, so we have this finalization mechanism called Grandpa, where the blocks are produced using some other mechanism, and then they're finalized using Grandpa, which can like finalize a batch of blocks, not just one at a time. And so during this like period between when a block has been produced and before it gets finalized, you can kind of like ping these validators and query them and make sure that they actually have their chunks. And so other validators will just randomly select like, okay, I was supposed to validate parachain 7 on this block, but I'm also going to just kind of like ping, parachain 42 and 47 and 63 or something, and ask for those erasure coded chunks and try to reconstruct their proof of validity block. And also like collators on their own parachain could be checking for this as well and say like, hey, I saw that one of my other collators submitted a block to you that you're currently like evaluating whether or not you want to include in the finalized chain. Give me all the pieces to that block so that I can reconstruct it and actually make sure that this data is available in the network so that I can have the right state to put on top of that. The fishermen actually come in and we're like, they can only check if that state transition is valid if the data is available to check it. So they're not only going to ask like, hey, give this to me, but they're actually going to execute it. And if they find out that this was executed incorrectly, then they would report this, and there would be some very large slashes taking place.
Thanks a lot, Joe. Yeah. And also one thing, first, just to mention, there was a question that came from the audience, so we will actually address it. But first wanted to actually touch upon something that you mentioned. I think it's very powerful in a state that this won't be a winner take all situation. I think we'll have many different blockchains that will have a different use or a different case. And there's a need in that context for interoperability. And also, I mean, in that light, we're very happy actually to pass the word to Zaki, who actually Cosmos has the longest track record actually in terms of the operating with their solution, if I can say it like that, a bit maybe provocative. So I think maybe for me, it was very interesting as well to when I was reading about, what I mentioned privately in the communication, a bit of a tangent approach to what we saw now. I think it would be very good if you can actually share a bit of your thoughts with your approach of the hubs and zones. Yeah. So if you can share a bit about how you see the operability in that context, and give the word, to the crypto dinosaur or the person with the longest track record in this panel. Yeah.
Yeah. So absolutely. I guess the sort of core, I'll pick up a couple of things that the previous speakers have said that we have picked a sort of different set of approaches and a different point in the trade-off space. So the first point that would be worth making about Cosmos is our scalability and interoperability solution is a live solution that is running today. It's been fully deployed as of 2 weeks ago. I was sending atoms between other blockchains in the Cosmos network just yesterday. And so I encourage people to actually go and try it out. And this is it's a cool thing that you can actually play with and start experiencing today. So that's one component of it. The second component of it is that we sort of fundamentally believe that different applications in the blockchain space will mostly bootstrap their own security. And this is sort of a natural outcome of the sort of evolving structure of blockchains, that there will be many blockchains, and that every blockchain will sort of bootstrap their own security to enable the users of that blockchain to have the amount of security that they desire for their application. Otherwise, they will use some other blockchain so, it's not, block space being fungible is not necessarily required for there to be many chains. It simply needs that users are able to sort of select a security level that they feel is appropriate for what they're trying to do in the space. The other thing is we have made sort of interoperability between these systems with varying security levels, basically completely native to the system. And so you get this experience of being able to have sort of native interoperability between chains, which is again something that I encourage people to try out with small amounts of money today. And so that would probably be the simplest solution. The other aspect of Cosmos is we tend to pursue a heterogeneous approach to solving all of these problems and to exploring different solutions in this space. We certainly have things, projects within our ecosystem. I would specifically point out Lazy Ledger as one of them, which is sort of pursuing a similar approach to sort of the Ethereum 2.0 and Polkadot approach of having sort of data availability sampling and multiple block producers committing blocks within the system. But that's rather than just being one way of doing things inside of Cosmos or the only way to do things inside of Cosmos. It's one way of doing things inside of Cosmos. And sort of our IBC protocol is able to actually bridge across these multiple approaches. So that's been basically the approach that we've taken. And I encourage people to start, these systems are real and people can use them today.
Thanks a lot, Zaki. And also maybe a follow-up question. If I recall correctly, one large centralized exchange used actually your solution to launch their own version of a decentralized exchange. The other one project that maybe I'm more fond of, which is Vega Protocol, that kind of also use similar approach. Kind of, if you can tell me, what do you see out there actually in terms of the end solutions that people are actually deploying or Cosmos use, or you actually use your solutions? Where do you see actually the appetite coming from? Is it more on the financial, and I kind of hinted at DeFi side, or is it something else? And where do you see actually the future for that in context of Cosmos? Yeah.
So in general, what I would say is in general, the financial side of blockchains is where the action is, right? And we keep seeing a number of large centralized exchanges have launched Cosmos SDK based chains. Specifically, again, in this model of they're able to bootstrap their own security in a way that users are willing to accept. Whether it's what Binance has done, where they run all their own validators, whether or not you pull validator capacity from the sort of large universe of validator operators. There's several hundred validator operators in the world right now. Different exchanges have run different strategies for doing this. But this seems to be working for their users. And it sort of seems to match what people actually need and require from a blockchain. As a result, a lot of the scaling solutions that are actually deployed right now are powered by Cosmos technology. So Binance Smart Chain is sort of, both Binance Smart Chain and Matic are sort of powered by the Cosmos sort of system architecture that we have been working on for all of these years. And so, yes, that's the sort of the state of the game.
Thanks a lot. Yeah, and I think also in terms of talking about decentralization, I think we'll have a lot more discussions going forward how these applications actually keep the decentralization being going forward. But I think definitely there's going to be room for discussions that going forward. And talking about feedback and discussions that we got, I'm happy actually to Jake actually asked a question from the audience. When he asked, do you think, in your view, there's still going to be a use for proof of work on smart contract blockchains that actually they have the ability of smart contracts functionality, or do you think actually the Bitcoin blockchain of Bitcoin is going to be the only one that's going to use it in the future? And maybe if somebody here as a tangent on this question can share their thoughts about Lightning Network, or if you have experience with that. I do, which didn't end well in 2017. But I'm going to open up this discussion, to the audience, to the panel, and hopefully somebody will pick up the question.
I'll bite.
Yeah, go.
Yeah, I mean, like, I think the context, or like the presumption that like the consensus is tied to the actual like state transition function of the blockchain is a little bit misguided, in that like, proof of work or just consensus in general, you have kind of like three questions to answer. Like, one is like who gets to author blocks, two is who authors the next block, and then three is which set of blocks is actually final. So like in proof of work, it just kind of like wraps all of these things together, where like who gets to produce blocks is anybody who has a CPU, who produces the next one is who like solves the next hash challenge, and then like which chain is final is like which chain is longest, more or less. Whereas on like proof of stake, we like different ways of like kind of electing like some validator sets, and then like choosing the next block author, and then like choosing which set of changes is final. But this is completely different from like the actual application of the chain, whether it's Bitcoin or Ethereum, Polkadot, Cosmos. Like the consensus part is completely different. And actually we kind of saw what happens with like the dilution and proof of work, where like more chains came in, and like if you wanted to start like the next proof of work chain, and that there's like, I don't know, however many like petahash per second available on like Bitcoin network, you're not going to choose SHA-256 as your hash algorithm for proof of work, because like 1% of one mining pool could come like completely destroy your chain. And it actually is like kind of in their incentive to do that, just like Google and Facebook kind of acquire their competitors. If you have 100 exahash power of some startup chain that is a competitor to you, it's very much in your incentive to go move some of your hash power over and destroy them. So I think that's kind of like motivated the shift to proof of stake, and why we initially saw like a bunch of these different kind of like obscure proof of work algorithms coming out. So I think there'll be like an increased trend towards proof of stake just in that regard. And I don't think with the application, whether it's like Bitcoin or like, some kind of like program of money versus like a computer or some other kind of network, really matters so much. And I think was just like the success so far of proof of stake, I'd be surprised to see more proof of work blockchains coming out, and Bitcoin just kind of might end up being the only one left, not so much out of like the consensus part, just more of like the legacy part.
I mean, I wonder if even in the long run, Bitcoin can withstand the pressure, because like I would say we're very, very quickly moving to the point where there's very little justification for having any proof of work chain around. Like proof of stake can just like provide much better security at this point, is basically proven. And how long will basically humanity tolerate us wasting these massive amounts of energy just because some people are too stubborn to move on, basically? I mean, I wonder. I don't know. Like, obviously it's very hard to predict, but I think even for Bitcoin, the pressure to move on might become so high that it might happen. Probably not very soon, but over 5 to 10 years, I don't know. I would think they should. Let's see.
Marcelo, Zaki, do you want to add anything to that? To give you the floor.
Sure. I will mostly agree with the other speakers that proof of stake consensus algorithms offer better guarantees. There may be a place for proof of work as a coin minting function for various projects. I can see why such a thing might continue to exist in the world. There's certainly sometimes advantages to being able to have a game in which you can take excess energy and convert it into magic internet money. But as a practical system for coming to agreement on application state, like proof of work is like is kind of like a ridiculous solution.
Yeah, I will also add that proof of work is actually more simple, and that's probably the reason it's a precursor in this area. But it's also very hard to scale solutions that relies on proof of work, and that's also another reason there's very likely not the technology that will be used in the future to power future blockchains.
Here for it's much easier to bridge a chain with deterministic finality, which is much easier to achieve with proof of stake than proof of work, because you actually, because you can answer the first question of who actually gets to participate in this. It's not unbounded.
Yeah, thanks a lot, guys. And also then to looping into the second question that we got from the audience. This one was specifically for you, Joe, so I'm throwing the hot potato to you. The question came from Kevin, who asked, can a parachain also be a relay chain for other parachains? So basically kind of to create a bit of a tree structure in terms of the subchains, yeah?
Yeah, that's in our long-term roadmap for Polkadot. So parachains, as they will launch very soon, will not support that. So it'd be kind of like individual blockchains, but definitely in our, like, say, 2-year roadmap, it's our goal to make these kind of like nested relay chains.
Got it. Thanks a lot. There is no further question, but then I'll throw maybe one last question that's a bit provocative. How do you, I mean, we're discussing now actually L1 solutions actually in terms of scalability, but do you see actually out there something that would, I mean, that's actually kind of what I saw actually from my industry, that people have a bit more short-term appetite for layer 2 solutions. And do you see that actually as a competition to what you're doing? Maybe not all of the projects specifically, but do you see that as an option going forward, talking about different ecosystems and how they serve our community?
I would actually like change that just a little bit, because I think like layer 2 solutions face a lot of similar issues than like the layer 1 solutions that we're talking about, like having multiple shards or multiple chains, where like if you have, say, one L1 with multiple L2s on top of it, then applications in different L2s need to go settle on the same L1. And if you have like multiple L1s, then they need to bridge or have some kind of like shared context, like over the relay chain. And so I think it really changes the programming model of the applications from synchronous to asynchronous. So we see like a lot of applications on Ethereum that are programmed with synchronous assumptions that they can like kind of execute a bunch of these contracts in such a way. Whereas like if you have an application that's built on L2 and it needs to interact with a contract on another L2, and it needs some kind of like settlement on L1 in between, or if you have 2 chains being bridged, or 2 parachains, or like 2 shards that are sending each other a message, then this becomes an asynchronous application. So if you want to do something like a flash loan, you can't just really like assume that this is going to be executed in a synchronous fashion. You might have to like do something and then, you know, have some like kind of like mutex that kind of like locks this part while you fire off some message to another L2 or another shard or another chain, and then wait for a response before you actually release that mutex. And so I would actually like put this question more toward like application developers, that they should be thinking about like how to program in an asynchronous environment across different blockchains or L2s or shards or whatever you're programming across.
So the other piece that I will just add is we've come up with a set of like very unique financial primitives that sort of enable things that are analogous to like functions like prime brokerage in the conventional finance, in like sort of legacy finance world, that have become very popular and successful in like the synchronous programming world that Joe was alluding to. And I think like most of the progress that is going to happen in the blockchain space, like I think in general, like the L1 like design space is like largely started to converge. Like Ethereum design space, the Polkadot design space, Cosmos design space, the Mirror design space. I don't think that there's actually anything that's like that unique and different about any of these things. They are all just credible blockchain platforms. What is going to be more interesting to see is now these like application primitives that sort of show up on top of like the wider Ethereum ecosystem, the wider Cosmos ecosystem, the wider Polkadot ecosystem. And we're just sort of starting to deliver enough functionality to developers for this to start to like come together.
Marcel, Dankrad, you want to add to this? Yeah.
So, I mean, from our perspective, I mean, L2 really means like some solution that that has the same guarantees as its base layer, right? That's kind of the idea behind it. So I don't count any kind of side chains that have their own honest majority assumptions. And then I think they don't compete with what we're doing. In the opposite, like we are actually leveraging them. The whole way we're designing charting now is actually to enable the L2s to scale much more. Like that's what we're trying to do. So I would say, yeah, we really encourage. We want more L2s on Ethereum, and yeah.
Yeah, on that side, I think that the same as previous panelists have talked, that this kind of application has similar issues to our current blockchains. On that side, I would add that on here we're working on this component, which is the EVM that will run in a synchronous environment, similar to how Ethereum works today, to enable actually those primitives that are very useful, those financial primitives that can only work on synchronous environment like flash loans and etc. So yeah, that's something that we can like have together in the same environment, like some sync primitive and some async primitive. But in general, to enable like scale applications, we actually need to think more asynchronously. That will also scale beyond current limits.
Thanks a lot, Marcel. Yeah. And let me then also ask another question that came in from the audience, and I think Joe, it's again for you. So the question is, does Polkadot actually allow communication between blockchains that are actually outside of the parachain? So like Bitcoin or Binance Smart Chain, Ethereum, and so on. Like, how do you see that? Yeah.
Yeah, I mean, it's just like any other consensus system, you need some kind of bridge between the two systems. So we do have in development bridges with Bitcoin and Ethereum, and maybe a few more, and then also substrate to substrate bridges. So we have, like we're going to bridge Polkadot and Kusama together. And then if you have like another substrate based chain, it's quite easy to connect that via kind of like a generic substrate to other substrate bridge. And then as far as like the other major networks, yeah, I definitely Bitcoin and Ethereum, and maybe some more as well.
Cool. So thanks a lot to everyone. We don't have any further questions from the audience, And I also just to reiterate, I think, the future is decentralized, and we spoke a lot about actually how achieve that goals with scalable solutions. Yeah. And also really thanks to everyone from the panelists from joining. I know, Zaki, I think you joined from quite a different time zone. So really appreciate that. And I hope the audience enjoyed this panel. And I thank everyone and, enjoy the time period. Yeah. Awesome. Thanks, guys. Yeah. Appreciate it.
Yeah. Thank you.
Bye. Thank you.
Thank you.
And shout out to the audience.